Alright, time for another draftphysics.com, debatephysics.com also, but again, this commenting debate thing doesn't work very well because they go way off the subject and then, there's nothing you can do about it in terms of commenters. You can't say, hey, you went off the subject, why don't you answer my question? Why don't you point out how it really works? Or why don't you point out why the evidence doesn't match what you claim, what your predictions are? So anyway, this Storks guy, Stonks, whatever, says, once again, all your argumentation comes down to not using work equals force times distance as a definition. Yeah, that's the whole point. I'm saying your math and your formulas are nonsense. Even your units are garbage, Newton and a joule. It's just about weight. It's pressure. Everything's pressure. So all I have to do is, I want to store some energy. I put a weight on something, and I get a certain pounds of weight, pressure. And I can use that pressure now to make things happen. And it's a certain pounds of pressure. It's weight. It's pressure. It's momentum. Okay? When I release the spring, right? The object sits on it. I release the spring. The object's going to move with a velocity, indicating a momentum. It's going to give back what gravity put in. That's going to be a momentum. So this was a momentum. This weight was just a momentum. That's the argument. The argument is your physics is convoluted nonsense, and the simple principle is all there is mass and velocity. That's all there is. There's nothing else. All right, now I've posed all these quandaries of your physics. So again, we can just do this simple illustration once again. Let's make this a 5 mass, and we'll make this the 10 mass. Okay, I put a certain pressure between them in a spring, okay, and launch them. And the simple argument is I'm going to get half the velocity going this way. That's going this way. So this will be a 10 velocity, and this will end up being a 5 velocity. And the simple argument now, your prediction is that this, okay, by your formulation, this can do more work. This has more joules of power and energy stored in it somehow. Its motion is 200, and this one's 100, if we just make it simple. I guess it's 250 and 500 is the real numbers, but anyway. Or 250 and 125, but who cares? The point is you say this object here has twice 2x, all right, the kinetic energy. And the simple argument is, what does that mean? If I crash it into something, will it do 2x the work? Will it in some way show that it has twice as much energy as the other object? Or is the simple truth that if I let these two things go and I had a little coil of rope tying them together and they run out of rope, what's going to happen? Is this one with twice as much energy going to pull this one in its direction? I mean, is there some other option? Does your physics predict something other than that? Can you draw me the equation for kinetic energy that shows that the kinetic energy somehow fails to work and the 5 mass going 10 doesn't pull the 10 mass in its direction because it has twice the energy? I mean, I'm quite certain, even though physics hasn't done the simple experiment, I'm quite certain that no, it will be a tie because the only thing that matters is the momentum, and they have the same momentum. And that's all that's going to matter. And I could do it the same way with bowling balls, right? We could just have the 8-pound ball going 16 and the 16-pound ball going 8, and then we could have them both crash into a solid steel object at the same time, hit the end at the same time. Is the whole piece of steel going to move in the direction where there's twice as much energy? No, it's not. So I'm making direct accusations that your physics predicts wrong outcomes. It doesn't predict accurately. It doesn't get right answers. It doesn't solve problems. All you do is do fake equations where you come up with some silly number and you say that's how it works in reality. And you never apply it to a real circumstance. Ever. Ever. So as long as it doesn't have anything to do with reality, you can get away with it because it doesn't matter. You can just say it's, the bomb is 100 million tons of TNT. You can just make up any number, and they actually did. Okay, I mean, when they tell you it's some sort of megaton, they just make the number up. Frankly, it's not even close to a scientific guess. Anyway, so I mean, the fact is your physics predicts wrong. It predicts that the 8-pound bowling ball going 16 somehow has more capacity to do work, and you can't make it do more work. There's no circumstance in which I can use the 8-pound ball going 16 and do more work than the 16-pound ball doing 8. You can't make it happen. You can't ever use this magical energy that you say exists. That's the point you have to respond to. You have to account for the fact that your physics doesn't work. It doesn't get a correct answer. It will not land you on the moon. If you use kinetic energy to decide how much thrust to use, you're going to overestimate how much opposite reaction you got from your thrust. You'll shoot out 30 joules, but the 30 joules is really only going to be, 10 newtons. Okay, it's not even going to be close. And you won't have navigated correctly, and you'll crash. That's the assertion I'm making. You have to counter the assertion with some sort of evidence that, no, your theory works. That actually will land you on the moon. That it will actually knock down more bowling pins. That somehow the faster ball, the lighter, faster ball, somehow can give the pins more momentum, right? That's all that can happen to the pins, is they just collect momentum, frankly. They go at mass and a velocity. You're claiming that you can make the pins go more mass velocity. You can give them more something, okay? more energy. And the energy can only be in the form of momentum. That's all you can ever transfer is momentum. The MV part is part of your own formula. Do you concede the point? Your own formula has MV in it, okay? So you have to start with that. You're going to give the pins more MV. No, you're not. All right, so that's the assertion. And so all this bullshit is just that, bullshit. So the other example I just recently brought up was this quandary of, I have a spring that has, let's say it has 30 pounds of pressure, so it's pressurized by 30 pounds. If I put it in gravity, 30 pounds would give it this much compression. All right. And we're just going to do two experiments. One experiment where it's connected to an immovable wall, and the other experiment where we're going to put an object on the other side of equal mass. So we have the same 30 pounds being applied. So what's your argument? Okay, is that they both go off with 30 pounds worth of pressure? That the ball here will go the same speed as the ball here? Because that's all you have is an opposite reaction thing. So, I mean, your physics says, well, this pushes with 30 pounds. This is the one moving. So this one's moving away. Their 30 pounds has to be going that way. That they're going to go the same velocity. And the argument I will make is, no, they're not. Okay, this one's obviously going to go twice as fast. Now, a little bit less than that because springs have an inefficiency. The faster the spring expands, the less capable it is of giving all its energy to an object. So as long as the spring's a lot less mass than the thing you're pushing, it won't matter too much. But springs lose a lot of energy the faster, the lighter the thing they're pushing. So that's just a fact. I'm asserting that's a fact. Do you disagree with that fact? Just like friction is variable. Now, I might play some clips from Professor Young, where he's talking about static friction and then friction, and they just give friction one number, as if any velocity creates the same amount of friction, when, of course, no, the faster you're going, the less friction there is. All right, per foot. Per unit of time, it's the same friction, but per foot, it's certainly not. So anyway, in this example, right, what do I get here? Do I get 30 pounds worth of, so let's say these were one masses, so we can make it kind of simple. I mean, do they both leave with 30 momentums? You know, or in this case, 60 momentums. Because what's the real fact? The real fact is that in this case, if I did this again, where I absorb the energy with a device, okay, what am I going to absorb? Am I going to absorb just 30 pounds hitting, or am I going to absorb the full 60 pounds hitting? And the correct answer is the 60 pounds. So I can't make the spring have 60 pounds. So obviously these two can't have the same amount of energy. I mean, it's just a simple fact that this will be the same total in one direction where you've split it in this direction. So in this case, it's essentially like you hitting a pool ball between two other pool balls. You can't give these ones velocity you don't have, or momentum. You can't give them more momentum than you start with. So you can't shoot them into the other two, shoot these two off, and now have a total momentum that's greater than the momentum you started with. So even though they have conflicting directions, they obviously aren't canceling each other. They're real motion in the universe, and all motion in the universe has to be accounted for. So this gets back to this, we'll read some more of his comment, and I'll just point out what's the point? You don't understand physics, because physics isn't about this nonsense. All right, using work equals force times distance. So what does that even mean? Work equals force times distance. So we know if I have an electric heater, all I care about is making heat, okay? And I'm going to make a certain amount of watts, all right, which is comparable to joules. And so where's the distance? There's no distance. I'm clearly doing work. It would be idiotic to say that the heater isn't doing any work. The electricity is going in, the voltage is dropping, it's doing work, all right? And the heat is the work. The fact is, the heat is a bunch of molecules moving. They're masses moving velocities. That's what heat is. Heat is you're making stuff move. It's movement in the universe. That's what heat is. So there's no distances here. You'd have to add up the distance of every single jiggling atom and figure out how much more distance they're traveling. Okay, their total, you have to add up all the jiggles and say how much total distance are the elements moving. And then you have to be able to figure out that you can't count the energy twice, because the energy is never going to convert to anything other than heat. In the sense it's going to leave is infrared radiation. So, I mean, it's always going to be heat. So you have to take it in some volume that you are going to measure how much that's moving. Because the heat just keeps moving through the universe is the argument, right? It always has to. The energy always has to keep continuing on its path. Now, this is one of the assertions that your physics doesn't seem to really care about what the word conservation really means. And, so I'm going back to Descartes and saying, yes, his observation that the universe was put in motion by God, it doesn't matter. It's in motion, and it doesn't need to be fiddled with, because the energy just keeps cycling, keeps moving. It's always on the move. And so all you can do is put it in small things, and then you can put it back in a big thing, and then you can put it back in a small thing. So gravity is a very small thing. You can put it back into the water that, created by the convection in the atmosphere, and you can end up putting it back in heavy things again. And you can put it in a reservoir, very heavy, so you can put it back in big mass moving. So there's no entropy that's a problem. Energy doesn't die as heat. The heat ends up compressing other things and creating the manifestation of bigger objects moving. The heat is converted into a big object moving, like us, for example. If it wasn't for the heat, we wouldn't be doing much, like a reptile. But anyway, so what's the point? Yeah, I'm arguing your definition of work, whatever the fuck that is, this special kind of thing. There's no distinction. It's only momentum. So, I mean, momentum, equals energy, okay, equals work, equals force, equals weight, equals pressure, okay? It's all the same thing. There is no capacity to make a distinction. If you're making pressure, you're doing work. If you're making weight, you're doing work. If you're making force, you're doing work. It's all work. It's all momentum. It's all matter moving. It's all mass and velocity. And that's all you have to conserve. There's a certain amount of mass moving in the universe, and it can either be in the form of big things moving or very small things moving. And there's always the same amount of that. And all objects can do is crash into each other and share what they have. So again, this gets back to the an argument that the NASA doesn't disagree with me, that it really doesn't matter whether the spaceship, okay, is going 20,000 miles an hour or, say, a clump of meteorite is going 20,000 miles an hour. All it's going to matter is that you're going to have a differential between these two objects that's going to be 20,000 miles an hour, okay? So it doesn't matter whether the spaceship crashes into the dust or the dust crashes into the spaceship. What you have to account for is 24,000, 24 times whatever the mass is, a certain amount of pressure. There's a certain weight differential between the two objects that adds up to a certain amount of weight, pressure. And that's all that's going to matter, is that the pressure differential when they hit each other. And because they're not elastic, obviously the spaceship is going to yield in both cases. In both cases, the particle is going to, hit a small surface area and break, no doubt, the egg of the spaceship. So, there's no disagreement, is there? That's the way it works. It doesn't matter what direction the pressure is being caused by. It doesn't matter whether somebody pushes me or I push them. All that matters is that this pressure is created, this weight differential between two objects. They collide into each other with a weight, a momentum. All right. So let's see. I don't know if there's much point in showing I'll show the text of the rest of it. There's no point. There won't be anything to say to the rest of it because it's all just junk. Where the hell's the mouse? Alright, should be back. Okay, so force times distance as the definition. That's right. I'm not using it because it's nonsense. It doesn't have anything to do with physics. It doesn't have anything to do with the physics that works. It doesn't have anything to do... Again, you have to show me the example where momentum, if I calculate momentum, I'll get a wrong answer. That's what you have to show me, the experiment where momentum gets the wrong answer. The examples are proven to be true. So, where? Where? That's the whole argument here. There's no example. You don't have any evidence. You don't have any car crashes. You didn't even do the simple tug of war. You haven't even done the spring on a brick wall, spring on a 10-pound object that can move on wheels. You haven't even done that. You have done nothing. Nothing. There's no experimental evidence. You've compiled nothing. You haven't even dropped 4 pounds 1 foot and 1 pound 4 feet. You won't even do that experiment. Let alone all the different experiments you could do with a gun. Putting different weight bullets in it. No, nothing. Nothing. Okay. Call it an abstract quality if you want. I'll call it garbage. That's what I'm calling it. It's not just abstract. It's incoherent to reality. It creates wrong predictions and wrong answers to simple questions. How fast will it go? You get the wrong answer. How do you land on the lunar surface? Do you calculate the kinetic energy of your thrust, or do you calculate the momentum of your thrust? Answer the question. But knowing force times distance has useful practical application. That's the whole argument. There's no practical application. Where? Show me. Show me where you get a right answer somewhere. You're predicting the 8-pound bowling ball knocks down more pins. Well, show me. And yes, the objects with the same momentum can have different force times distance quantities, whatever that even means. So yes, the whole point is you're saying that momentum, okay, isn't fundamental and elemental, and that somewhere it gets a wrong answer. I'm saying show me where it gets a wrong answer. For example, if you have an object speed, velocity, and a distance it's traveled. So again, you keep playing with this idea that all motion is in some measurable distance. What's the distance in the explosion of a piece of dynamite? What kind of nonsense distance? You can't use any nonsense distance. There's no distance to figure out how many joules of energy the explosion has. The only way we can tell is by putting different weights and seeing what happens. And then trying to understand that, well, it makes a difference, in terms of, what kind of variables are going to affect the objects we put in there. But it's going to be pretty close to the truth that momentum is always going to come out of the gun. Because the explosion is not like a spring. It's not handicapped. Okay, it's going to be really effective at giving light things velocity and giving heavy things velocity. It'll do both very well. Then you can calculate the force applied over the distance so this is just more crap. Why would I calculate incorrectly? Why would I assume velocity times velocity? Where is it shown to be true anywhere? Show me the experiment where it's true. All right, so work equals force times distance is a useful quantity to solve for an unknown. It's not useful. It doesn't get right answers is the argument. So again, you show me. Show me the ballistic pendulum where you collect more than 0.06% of the kinetic energy. Because obviously if you collect 2%, let's say, you'll end up creating free momentum. And then you'll have to explain how you made free momentum. And why that isn't free energy. Why free momentum isn't free energy. So, superior mind, okay, I'll read it. I don't always like his explanations, but whatever. Work under the definition is somewhat misleading and inconsistent. It's not somewhat, it's always wrong. Okay, because it really doesn't have anything to do with any kind of distance. Distance isn't going to tell you the truth, just like with the rolling object. The distance isn't telling you the truth. Denting the clay, the distance you penetrate the clay, isn't telling you the truth. All right, how do so many physics words have so many different circumstantial definitions? Well, the fact that none of these formulas do work universally is a point to raise about how they're probably not getting to the elemental function. So it's like MGH. MGH only works if the object doesn't have any initial motion. But MGT works regardless of whether it has motion or not. So MGT is clearly the superior formula because it always gets the right answer. So in this circumstance, it looks to be an abstract concept of measurement. It's not just abstract, it's wrong. I mean, it's wrong. It doesn't get correct answers. Let's not even talk about polarity. I don't know. Related applied force over distance. But in other circumstance, and never mind that everything in the universe in some combination of forces interacting with matter. So it's just momentum interacting with momentum. The force, the photons, the magnetic forces, all these forces are able to impose momentum, okay? And they're really doing it between electrons and protons. And that's the simple fact. But the force has the capacity to give material, electrons and protons, motion. And that's the important fact. And it's in quantizable chunks. All right. The absence of, like when matter is ejected from one side of it and offsets the balanced force influence from the surrounding universe. Let's say if I poke, there's a blob of water in space, and I poke it. What can happen? Does the water move with the poke? Or does the internal structure of the water oscillate? Right? And so that's a question that can be asked. And it would oscillate in a, like a Earth's gravity in a parabola, because it would keep the first motion still is the first motion. But it's going to keep counterbalancing its own torque in a direction. It's going to keep stopping and starting. If you use 1/2 mv squared to calculate total force applied, you'll get a rough approximation in some circumstances at best. So the point is they've tested none of it. So the point is the only time it gets right answers is when you're transferring energy from like masses. So if you have the same object with the same mass and you're transferring the energy to an object that's exactly the same mass, you're not going to have a problem with kinetic energy. But in every other case, you're going to have a big problem because it won't work. It won't create the extra momentum you claim it can produce, the extra work. And in cases like, where you add 5 mass to a 5 mass moving 10 and you make it into a 10 mass going 5, you completely conserve the momentum and you lose half the kinetic energy. And there's no evidence you lost it to anything. There's no evidence that you did actually lose it somewhere. It's not going somewhere. It's not flying off into pieces. It's not doing any of that stuff. All right. If you want to find out how much force and momentum it has, you're better off knowing its velocity and mass. Well, you have to either way. You have to know its velocity and its mass, but you're better off stopping right there and recognizing that's all there is. Mass is moving. Electrons and protons are the universe, and their motion is our motion. Nothing moves until the electrons and protons do it first. Just a fact. Alright, that is all we use in game physics engines, rapid body dynamics, and it's what NASA has been using. I've never even seen a kinetic formula in any of the applied game physics books. I've seen MV and Hooke's and a mess of other messy things, but no KE. So again, the point is that yes, we're this is all about showing, evidence. So no point in you predicting something you don't apply to an actual experimental case that can be tested. So without testing it, it's useless. And unfortunately, they do tests, where they don't care about all the other variables, the friction, and they don't care about angular rotation of wheels, and they don't care about all these other places you can lose some of the energy. And again, the spring argument is just so obvious. I wish I had a big spring. I should find a spring for the purpose. But I mean, look, if I'm holding a spring, I compress it and then I release it. You can understand if I release it and it's just pushing air, right? It goes its fastest velocity, it pushes some air, and then it just sits there and oscillates. And it's going to oscillate a lot at a high velocity because it didn't give any of its energy to anything. It still has it. It's stuck in the spring. All right. And the simple argument is that the heavier the mass I put on there, the slower the speed the spring will be going when it releases the object. When the object goes away from the spring will be going slower and slower and slower. The slower the spring is going, the less it's going to oscillate, meaning the less energy it's left in the spring. So the heavier the object, the slower it's going, the more energy the spring will give it. And the lighter the object, and the faster the spring is going when the object leaves the spring, the more energy that's still stuck in the spring. I mean, that's not a defeatable argument. It's physical fact. And if a physicist isn't going to pay attention to those physical facts, what can you do? I mean, they can't understand an argument like paint spray. I got the paint sprayer on. It's shooting a constant force of paint. I move very quickly through it, and there's very little paint on my hand. I've moved very slowly through it, and there's a ton of paint on my hand. I mean, I have to explain that to a physicist? That's exactly what gravity's doing? The faster you go through it, per foot, less weight you're applying to the surface. Yes, over the complete unit of time, 1 second, you'll get your 9.8. But obviously, 1 second that's over this much surface is very different than 1 second over this much surface. Obviously, if the total trip is half the amount of time, then I can't possibly be affected by this, the full amount of gravity. If I took half the time exposed to the gravity, then obviously I can't have been affected by the same amount of gravity because it's in units of time. So if something rolls 4 times as far, but it's only in the gravity twice as long, you should be able to do the math and figure out that, oh, well, the reason why it rolled further is because, it's twice the velocity and 2 units of, gravitational friction. Anyway. All right, well, I'll take a pause, I guess, and see. Well, maybe I'll just, if I have to add something, I'll add something, and if not, I won't. I'll just wait till later to post this one, I guess. We'll see if anything shows up by morning. Any other comments? Yeah. It's just so bad. Yeah, no, I think it's enough of a video. Maybe I'll just upload it now. Yeah, 31 minutes. That's enough of, enough arguments in here that, and they won't be countered. They won't be refuted with evidence. They won't show the 8-pound bowling ball going 16, knocking down, making pins move with a single bit more momentum. Not a single bit. They won't show us the 16-pound ball going 8, failing dismally, to give pins momentum. Because momentum is all there is. Nothing else. There's nothing else going to happen when bowling balls of any mass hit pins. It's just not going to matter. All it's going to matter is what's the momentum. Only the momentum can be transferred. Kinetic energy can't be. Fact. Because it doesn't exist. Fact.